All right, today we're jumping back in time to explore the very dawn of mobile freedom. We're talking about the first generation of wireless communication, what we all know as 1G. This is the tech that finally cut the cord and put a working phone inside a moving car for the very first time.
So just try to imagine a world with no texting, no mobile internet, a world where just making a phone call without being physically plugged into a wall was a complete revolution. What was that actually like? Well, that was the world of 1G, and it's a pretty fascinating place to start our journey.
Back in the early 1980s, for the very first time, you could literally be walking down the street and take a phone call. It seems so simple now, but this was the dawn of mobile telephony, the first giant leap away from the landline.
So how did this magic actually work? Let's get into it and break down the fundamentals of the very first mobile network.
Okay, the first thing to get your head around with 1G is its simplicity. It was purely analog. That means it sent your voice over the air as a continuous radio wave, kind of like how your car radio works. And because of that, it could only do one thing: handle voice calls. That's it. No data, no texting, nothing. It operated in the 800 to 900 megahertz frequency range and used a system to manage the calls called FDMA.
So how did this analog system manage to keep a call connected while someone was on the move? Well, it really came down to two key things: the way it managed the airwaves and how the physical network was built on the ground.
The secret sauce to 1G was something called Frequency Division Multiple Access, or FDMA. Now that sounds super technical, but the idea is actually pretty simple. You take the big chunk of available radio frequencies and you just slice it up into tiny individual channels, and each and every phone call got its own private channel.
But, and this is a huge but, this approach had a massive drawback. Once your call was assigned a channel, that little slice of the airwaves was yours and only yours for the entire conversation. Nobody else could use it. Even if you were both totally silent, that channel was locked down. As you can probably guess, this was incredibly inefficient.
A great way to think about it is like this. For the few minutes you were on a call, you basically had your own personal, private radio station. Your phone was broadcasting on one frequency, and the cell tower was broadcasting back on another. Super simple, but not a great way to handle lots of users.
So that's how they divvied up the airwaves. But what about the actual hardware on the ground? Well, the network was basically a big patchwork quilt of geographic areas called cells. In the middle of each cell, you had a tower, or a base station. And then, watching over all these towers in a region was the brain of the whole operation, the mobile switching center.
Think of the base station, or BTS, as the local muscle. It did the heavy lifting of talking directly to your phone with radio signals. But the mobile switching center, the MSC, that was the real intelligence. It was in charge of managing calls, keeping track of billing, and, most importantly, performing the magic trick of keeping your call connected as you moved between cells. That process is called the handover.
Let's actually see how that handover was supposed to work. Imagine you're in a car on a call. Right now, you're connected to the closest tower. We'll call it base station 1. The signal is strong, the call sounds great, everything's working perfectly.
But as you keep driving toward the edge of that first cell's coverage area, the signal from base station 1 naturally starts to get weaker. At the exact same time, the signal from the next tower up the road, base station 2, is getting stronger. The network knows it needs to make a decision, and fast.
And there it is, the handover. The MSC, the network's brain, seamlessly switches your call from the tower with the weakening signal to the one with the stronger signal. It even assigns you a brand new frequency channel in that new cell. In a perfect world, your call continues without you even noticing.
Yeah, about that perfect world, that seamless handover was often more of a myth than a reality. These early systems were clunky, they were slow, and as the source material points out, it was incredibly common for calls to just drop right in the middle of that switch. The dream of mobile freedom would very often end in just frustrating silence.
So when we take a step back and look at 1G as a whole, what's the final verdict? Well, it was a revolution, for sure, but it was a deeply flawed one. Let's really weigh the pros and cons.
On the one hand, what 1G did was groundbreaking. It delivered on the promise of true mobile voice calls, and it brought coverage to places landlines just couldn't go. But wow, the limitations were severe. Voice quality was often awful, just full of static and interference. The network capacity was low, and those infamous brick phones, terrible battery life. But maybe the single biggest problem was security, or more accurately, the complete and total lack of it.
The problems were just baked right into the analog system. First off, there was no roaming. A phone from one network was just a useless brick on another one, and this was made even worse by a whole mess of incompatible standards across different countries. But the most shocking flaw by far was the zero security. Because the calls were just simple, unencrypted analog radio waves, literally anyone with a basic radio scanner could listen in on your private conversations.
And as our source material puts it so bluntly, this situation, especially the lack of security and all the incompatible systems, was simply unacceptable. The industry knew it. They had to come up with a better, more secure, and way more efficient digital solution.
And so, the era of 1G was always destined to be a short one. It was the pioneer, it was the proof of concept that this could all work, but its own flaws basically guaranteed that it would be replaced.
So at the end of the day, here's the crucial takeaway. 1G was the essential first step. It was the analog foundation that proved to the world that mobile communication was actually possible. But its terrible quality, its low capacity, and its massive security holes made the jump to digital not just a nice little improvement, but an absolute necessity. It completely paved the way for the 2G revolution and really everything that came after.